Hi, this is a demo of Vibe. Vibe is an RLOps platform which allows RL engineers and ML engineers ability to seamlessly orchestrate experiments on cloud. This demo is going to show how easy it is to schedule experiments in Stable Baseline's PPO agent and DQN agent, both of which are already integrated with Vibe. To orchestrate an experiment, first thing we would need to do is to create an environment. For purposes of this demo, I'm going to go ahead and create a new environment. I'm going to start by creating a requirements.txt file. This requirements.txt file is going to be installed during the experiment orchestration. So once the experiment starts, this requirements.txt is going to be installed and then available for the other Python files that are going to be available inside the this environment to use. So for the purpose of the demo, I prepared a environment, and as I said, it depends on several things, some of which are NumPy, Pandas, YFanas, Gymnasium, and so on and so forth. And the requirements.txt is what's going to allow this environment to resolve some of those dependencies. The biggest requirement for this files in this environment is the fact that there should be only a single environment, a single class which extends Pharma Foundation's environment, which is right here. As we see, this is a single stock trading environment which extends the Pharma Foundation's gym environment, and then all of those dependencies can easily be resolved by this requirements.txt. So I'm going to go ahead and name this environment stock trading demo, and then I'm going to upload the environment. And then as we can see, we got the confirmation that the environment was successfully created. As we can see, the environment becomes available right here. And our next step is to simply go in and schedule the experiment with the environment which we just created. To do that, we would head over to the experiments page and then click on create new experiment. I'm going to name the environment the way I would have named it, however I see fit. For time steps, I'm going to give 100, and then memory configuration is gigabyte, and I'm going to choose stock trading demo, and insert the startup parameter map right here. This startup parameter map is what allows us to repeatedly schedule the experiment with different initial conditions. So this is one of the most critical portions, and I'll return to this in just a bit. Just for the time being, let's remember that buckets, loopback, RSI, symbol, memory interval size, start, and end date are what the startup parameter map was for this environment. So as I said, there's two types of agents integrated already, PPO agent and DQN agent. And here you could tweak the hyperparameters of either of the agents. There's basic parameters and advanced parameters. So if you choose the PPO agent, you could come in and tweak the hyperparameters as well as the advanced parameters, and then obviously just simply schedule the experiment. And just as easy as that, we scheduled the experiment. Now going back to the startup configuration map, what is the startup configuration map? If we view the environment, which we can easily do by just clicking on view environment, we will see that there's init method, and init method has exactly the same parameters as the startup configuration map, which are buckets, loopback, RSI, symbol, memory interval size. So the keys of that match with this. So that's exactly why they're called the startup configuration map. So I just wanted to quickly show you that. And we see that the environment is in pending state. Meanwhile, while it's pending, I wanted to show you quickly what the DQN experiment scheduling would look like. Just as we did for PPO, we would head over to the create new experiment, name the experiment, and choose the time steps, and then choose the memory configuration. Memory for DQN experiments, we probably want to have a higher memory because they have Ray is relatively a more memory consuming library. And then we choose the stock trading demo environment again, paste in the and then we could change this to anything we want, maybe like a different time frame or a different symbol or whatnot. But for the time being, I'm just going to leave it as is, change it to DQN agent, and leave the default parameters, and then I'm going to schedule the experiment. And just as easy as that, we scheduled the DQN experiment as well. Now, another positive thing happened. Now we see that the other experiment which we scheduled, the PPO one, actually succeeded, and we can view the rewards. So this is how the agent performed across the 100 time steps that we asked it to train. And obviously in a real life scenario, you would train it for far longer. And then I just wanted to quickly show you how easy it is to deploy this trained agent to production. Click this. That's it. It's deployed to production. Now, just as easy as that, our stock simulation experiment, it becomes an RL agent. So we click on this, and then we can come in here and then query it. And here we go. It actually, I queried it with this observation. Obviously, you can change this, and this obviously is going to be available through a RESTful API and a Python client. But to illustrate the point, this is how easy it is to deploy this through Vibe, and then also to query it and then get the action. So this action space is what the environment action space is, and it actually gave us action of 0, which is the discrete discrete action space, one of the actions in the discrete action space that we actually had on the environment. Going back to the experiments, here too we see the DQN agent finished as well, and just as easy, just as with the PPO agent, you can easily view it and just see because it was a very small, so there's only one epoch that it actually played through. So we don't really have much in terms of rewards or anything like that, but if we wanted to obviously deploy it, we could deploy it and start querying it. This pretty much wraps up the demo. Hopefully RL engineers and ML engineers are gonna find use for this tool. So I just wanted to quickly share with you what the current Vibe state of current Vibe looks like.